Chapter 24, Planetary Geology. Our solar system, an overview. The solar system includes the Sun, 8 planets and their satellites, asteroids, comets, and meteoroids. Now here's a map of our solar system, and here's our planets out from scale. So the Sun, then Mercury, the tiniest, and Venus, Earth, Mars, and Jupiter, Saturn, Uranus, and Neptune. So here in map form, the Sun, Mercury, Venus, Earth, and Mars, and then we have the asteroid belt and the outer planets, Jupiter, Saturn, Uranus, Neptune, and the Kuiper belt. Nebular theory, the formation of the solar system. The nebular theory explains the formation of the solar system. The Sun and planets formed from a solar nebula, a cloud of interstellar gases and dust. The solar nebula contracted, most material collected in the center to form a protosun. The remaining material formed a thick, flattened, rotating disk around the protosun. Repeated collisions of particles in the disk formed the planetesimals, asteroid-sized objects. Repeated collisions of planetesimals formed protoplanets, Mercury, Venus, Earth, and Mars. Far from the Sun, ices, water, carbon dioxide, ammonia, and methane also contribute to the formation of planetesimals and protoplanets, like Jupiter, Saturn, Uranus, and Neptune. Now the planets' internal structures and atmospheres. We have two major groups of planets. The terrestrial planets, like Mercury, Venus, Earth, and Mars. They're Earth-like inner planets. And the Jovian planets, Jupiter, Saturn, Uranus, Neptune, with Jupiter-like outer planets. Okay, the internal structures. Early segregation of material by chemical separation led to the layering of the planets. Terrestrial planets have iron-nickel cores and silicate crusts. Jupiter and Saturn have small iron-rich cores and hydrogen and helium outer layers. Uranus and Neptune have small iron-rich cores, ammonia and methane mantles, and hydrogen and helium outer layers. So here's comparing the internal structures. So we're familiar with the Earth structure, the core. So here, so the rocky crust, the rocky mantle, metallic core, and the inner metallic core. The Moon, they have a little core, a mantle and a crust. Mars has a core, a mantle, and a crust, and so does Venus and Mercury. Jupiter and Saturn, they have rocky inner iron core and liquid metallic hydrogen, okay, and liquid molecular hydrogen and gaseous hydrogen and helium. And the outside, they also have visible clouds and ices. The atmospheres of the planets. Solar heating and gravity affect the thickness of a planet's atmosphere. The Jovian planets have very thick hydrogen and helium-rich atmospheres. Terrestrial planets have thin atmospheres composed of carbon dioxide, nitrogen, and oxygen. Okay, the atmosphere, okay, this axis is charged solar heating, and this axis is the gravity, okay? And, airless worlds have relatively warm surfaces and temperatures and or weak gravity. So our airless bodies are up here, and then on this side of this chart here, and then air bodies with atmosphere on this side of the chart. Okay. Planetary impacts. Impact craters are a result of planetary collisions with massive bodies. Meteoroids with masses less than 10 kilograms lost 90% of their speed as they passed through Earth's atmosphere. Planetary impacts were more common in the early formation of the solar system, for periods of intense bombardment. So when we have an impact, we have a crater form. So here's the impact, the compressional wave, and then we have rebound of overpressed rock, debris explodes out and is ejected, and this and there's also fractured rock. So then maybe some magma may come out of the fractures. We end up with a belt of ejecta and a raised rim from this. There's some crater impact. The Moon is the largest satellite relative to its planet. The general characteristics: its diameter is over 3,000 kilometers, it's a quarter of the Earth's diameter. Temperature variations of 107 degrees Celsius to minus 153 degrees Celsius. Its density is 3.3 times that of water, and is 1/6 the gravity of Earth. How did the Moon form? The result of a collision with a Mars-sized asteroid 4.5 billion years ago. Earth was semi-molten. Debris from the collision were ejected into orbit around the Earth. The particles eventually coalesced into the Moon. The lunar surface has two types of terrain. The Maria, smooth plains of basaltic lava, and the Terrae, or the lunar highlands, breccias elevated several kilometers above the Maria. impact craters. Because the moon has no atmosphere, a 3-meter wide meteoroid can create a 150-meter wide crater. So here's the moon. So here we have the Maria, the dark areas, and the lighter areas are our highlands. Formation, okay, history of the lunar surface. Formation of the original crust, 4.4 billion years ago. Magma ocean began to cool, underwent magmatic differentiation. Dense minerals sank. The less dense silicates floated to the surface. Most common highland rock is anorthosite. Excavation of large impact basins. Lunar crust was bombarded by debris. Frequency of bombardment decreased about 3.8 billion years ago. Filling of the Maria basins. Maria-based basalts are 3 to 3.5 billion years old. The formation of rayed craters. Meteoroid impacts are younger than the Maria. Rays are lightly colored ejecta material. Examples, the Copernicus crater. Today's lunar surface, weathering and erosion. Lack of atmosphere and flowing water on the moon. There's no tectonic forces. Erosion is dominated by impacts of tiny particles from space. Continually bombarded surface and mixed upper layers of lunar crust. The crust is covered with a soil-like lunar regolith, composed of igneous rocks, stretched like glass beads, and lunar dust. Mercury is the innermost planet. The innermost, the smallest planet, revolves quickly, rotates slowly, greatest temperature extremes in the solar system, absorbs most of the solar radiation it receives, has a magnetic field, a hot fluid core, vast smooth terrains and heavily cratered terrains, and lobate scarps. Here are some pictures of Mercury. Venus, the veiled planet, second to the moon in brilliance in our sky, rotates in the opposite direction as the other planets, similar size to the Earth. Densest atmosphere of the terrestrial planets. Its atmosphere is 97% carbon dioxide. It's a really hot planet. Surface marked by lava flows, craters, and planets. So here is a radar recreated image of Venus. We can't really see through its atmosphere. Mars, the red planet, is half the diameter of the Earth. Its atmosphere is 1% as dense as the Earth's, primarily carbon dioxide. There's 2 hemispheres in Mars, and Mars actually is home to the largest volcano in the solar system is Olympus Mons. Has also some of the largest canyons. Topography, pitted with impact craters filled with dust. The reddish color is due to iron oxide. Period of extreme cratering ended 3.8 billion years ago. 2/3 of the surface is heavily cratered Martian highlands. 1/3 of the surface is younger lower plains. Volcanoes on Mars. Volcanism prevalent throughout Martian history. Olympus Mons is the largest volcano in the solar system. It resembles a shield volcano. Volcanoes are large because plate tectonics is absent on Mars. So that's how big Olympus Mons is, big as a southwestern state. Water ice on Mars. Ice is found within a meter of the surface poleward of 30 degrees latitude. Permanent ice caps are found on the poles. Liquid water once flowed on Mars, created stream valleys and related features. Water-colored features on Mars. Jupiter, floor of the heavens, largest planet, 2.5 times more massive than combined mass of all the other planets, satellites, and asteroids in the solar system. 3 main cloud layers, the innermost blue-gray layer of water ice, middle orange-brown layer of ammonia, hydrosulfide droplets, outermost white layer of ammonia ice. Due to immense gravity, Jupiter is shrinking. Contraction generates heat, which drives atmospheric circulation. It has dark-colored belts, cool materials sinking and warming, and light-colored zones, warm materials ascending and cooling. So here's its belts of cloud, the dark sinking clouds and the rising bright clouds. And in between, these strong winds are generated. Great Red Spot is an enormous storm, twice the size of Earth, observed for over 300 years. Magnetic fields generated by liquid metallic hydrogen layer, strongest in the solar system. Bright auroras associated with the magnetic field. So here's Jupiter's auroras. Jupiter's moons. Jupiter has 67 moons. The 4 largest moons are the Galilean satellites that Galileo saw with his telescope. Ganymede has a dynamic core and magnetic field. Callisto. Io is the most volcanically active body in the solar system, and Europa, covered with ice, possibly liquid water under the ice. So here are some pictures of those Galilean moons. Io, Europa, Ganymede, and Callisto. Jupiter's rings are composed of fine particles similar to smoke particles. Now Saturn, the elegant planet, similar to Jupiter in atmosphere composition and internal structures. Saturn's moons, we know of 62 of them. Titan is Saturn's largest moon. It's larger than Mercury, has substantial atmosphere, Earth-like geologic landforms, and caused by methane rain. So here's a picture of Saturn. And here's the rings. Saturn's ring system composed of small particles, water ice, and rocky debris that orbit the planet. Most rings fall into one of two categories based on particle density. Thought to be debris ejected from the moons. The origin is still debated. Okay, so here's the echo gap between some of the rings, and here's one of its moons there. And here's, I'll probably zoom in of that moon. Uranus and Neptune are twin planets, both equal in diameter and bluish in appearance, result of methane in the atmosphere. The mantles are water, ammonia, and methane. Uranus is a sideways planet, rotates on its side due to a large impact. Uranus's moons have varied terrains. Uranus's rings are 10 sharp-edged rings orbiting the equatorial region. Here's a picture of Uranus. Neptune, the windy planet, dynamic atmosphere, one of the windiest places in the solar system, large dark spots of short-lived storms. Neptune's moons are 13 satellites. Triton is the largest Neptunian moon, has an atmosphere, has cryovolcanism, eruptions of water ice, methane ice, ammonia ice. Neptune has 5 rings. Okay, here's a picture of Neptune. There's a great dark spot. And you see cirrus-like clouds and a dark spot with a bright core. Now, asteroids are leftover planetesimals. Asteroids are small bodies left over from formation of the solar system. Most orbit in the asteroid belt between Mars and Jupiter. Some are very eccentric orbits, so very elliptical orbits. 1,000, 2,000 Earth-crossing asteroids. So here's the asteroid belt. Comets are dirty snowballs. Comets are also leftover material from formation of the solar system. Loose collection of rocky material, dust, water ice, and frozen gases. Most reside in the outer reaches of the solar system, take hundreds of thousands of years to orbit the Sun. Some short-period comets, orbital periods of less than 200 years, for example, Halley's Comet. Structure and composition of comets, a small central body called nucleus. Escaping gases and dust around the nucleus is the coma. As a comet approaches the Sun, most develop a tail that points away from the Sun due to radiation pressure and solar wind. So here we have a comet with its coma, and here as it's traveling closer to the Sun, its tail is going to be pointing away from the Sun. The realm of comets, the Kuiper Belt and Oort cloud. The Kuiper Belt exists beyond Neptune and contains comets that in orbit around the Sun. Halley's Comet originated in the Kuiper Belt. The Oort cloud consists of comets distributed in all directions from the Sun. Only a tiny fraction of Oort cloud comets come into the inner solar system. Meteoroids. A meteoroid is a small solid particle called meteors. When they enter the Earth's atmosphere, they originate from interplanetary debris, material ejected from the asteroid belt, rocky metallic remains of a comet. Meteor showers. A meteor shower occurs when meteor sightings increase to 60 or more per hour, associated with debris ejected from comets. Meteoroids are large enough to survive passage to the Earth's atmosphere, originating from the Earth's asteroid belt. Types of meteorites. The remains of meteorites found on Earth are referred to as meteorites, classified by composition. The irons are aggregates of iron with 5 to 20% nickel. The stonies, or chondrites, are silicate minerals with inclusions of other minerals, and carbonaceous chondrites contain organic compounds. Stony irons are a mixture of stony and iron. So here, there's a meteorite crater where there was an iron meteorite that hit. Dwarf planets are round and orbit the Sun, but are not large enough to sweep debris from their orbital paths. Pluto is a dwarf planet. It's smaller than Earth's moon. Other dwarf planets include Eris, a Kuiper Belt object, and Ceres, the largest known asteroid. Here's a picture of Pluto, and Charon is one of its moons.